Welcome to Ask and Learn.
Here we have a truck traveling at 40 kilometers per hour, which skids 3 meters before stopping while applying the brake. We would like to determine how far the truck will skid if it is traveling 80 kilometers per hour when the brakes are applied. Okay. First, we will start with a kinematic equation not involving time, since we are given the distance of 3 meters here rather than the time. That equation is simply v final squared minus v initial squared equals 2 multiplied by the acceleration multiplied by distance delta x. So the acceleration a occurs over a distance delta x equal to 3 meters. So the right-hand side, let me write it right below. Right-hand side becomes 2 times a times 3 meters. The left-hand side, well, v final has to be 0 because the truck completely comes to rest after slamming on its brakes and skidding to a halt. So that will be 0 squared minus 0 squared minus 40 kilometers per hour squared. Okay. Oops. Okay. So 40 kilometers per hour and 3 meters. These are clearly different units, and we're going to have some trouble here. So we should first convert one of the units into something compatible with the other one. So to do that, I'm going to convert 40 kilometers per hour into meters per second. To do that, I'll convert kilometers first. We know that 1 kilometer will be on the bottom to cancel this kilometer. And we know that 1,000 meters are in a kilometer. Then we want to cancel the 1 hour with the amount of seconds. That's 3,600 seconds in an hour. That's just 60 times 60. So, bringing the calculator, 40 times 1,000 divided by 3,600. That gives me 11.1 repeating meters per second. Okay, that's the initial velocity. Okay, then remember that's going to be plugged in over here. 11.11 repeating meters per second squared equals 2 times a times 3 meters. We can square that 11.11111 to get 123.5 approximately. That's going to be negative, which makes sense because the acceleration has to be negative in order to slow down the truck. The acceleration will be in the direction opposite to the motion in order to slow it down. So we'll have negative 123.5 meters squared per second squared equals 6 times a times the unit of meters, right? We have meters over here. One of these meters will cancel with this meter, one of these meters over here. And we can divide by 6. And we get 20. We get that A is equal to negative 20.576. So let's say 58 meters per second squared. This is the acceleration. Okay. Now we will be able to calculate how long it will take in distance to stop when the velocity is 80 kilometers per hour instead of 40. So we'll set up the same kinematic equation, except now v0 will be 80 kilometers per hour, and we will know the value for a, and we will calculate the distance delta x. Once again, v final is 0 because we're slamming on the brakes to stop. Here we'll have to convert 80 kilometers per hour into meters per second. But since we did this conversion up here, we know that if we double everything on the left-hand side, we'll be able to just double everything on the right-hand side, right? If 40 goes to 80, then 11.1 has to go to 22.2, repeating. So that's just a quick trick. You could convert it again by hand. Let's plug that in. And we have equals 2. Now we have the acceleration to plug in that we just calculated, multiplied by some unknown distance, delta x. Okay, so let's go back here. Okay, so we have 22.2 repeating squared. Oops, let's see, let's try that again. 22.2 squared. Jeez, 22.222 squared. It's going to be negative, but the negative will cancel on either side of the equation. So we can divide by 2 and then divide by 20.58. That gets me a value delta x equals 12 meters. Now, an interesting note about this problem is that we had 3 meters to slow down from V0, 40 kilometers per hour. Now, when we double that V0 to 80 kilometers per hour, we might expect that the distance would double. But in fact, instead of going from 3 meters to 6 meters, it actually goes 3 meters all the way up to 12 meters. So the faster you're driving, the longer it will take to brake and come to a complete stop. And it will actually take a bit longer than expected.